This is an update of my developments of an ultra secure platform and an ultra secure application that's running out. My last update on this platform was about 1 year and 3 months ago. Subsequent to that, about a month after it, this room that I'm working in and the building was flooded a few feet, so it all had to be rebuilt. So over that year and 3 months, much of the development time was consumed by reconstructing this building. Anyway, at that time, I had a framework developed wherein uh, inside of a web application was being secured more so than in standard other applications from other organizations. I emphasized that TLS was very good out on the internet for securing the data that goes to and fro organizations that are serving web applications. TLS revolves around a certificate authority, and the private and public keys of a certificate. TLS works very well with certificates if you keep the private keys secure, and therefore the data going between the organization and consumers out in the world can be remain secure and confidential. The way that works is an organization will send out a certificate, and then the world, somebody out in the world can ask the certificate authority whether that certificate is valid and that they are therefore talking to the organization in question. The issue that I have observed while developing software for a couple of decades is that within the organization there is not a lot of security of data. And large organizations such as Facebook, AWS, Google, eBay, etc., and your banks don't really use TLS on the inside. And if they did use TLS on the inside, it'd be very difficult for them to secure the secret key, which has to be virtually kept away from everybody. Anybody who would have access to that secret key would be able to surveil the data that goes around here, including your banking data and any kind of private chats that you might have, etc. And in fact, it is an industry to get this key and observe data even outside the organization. That's presumptively done to make sure that nefarious purposes are not being achieved with the internet data, but it also compromises your security by letting other people that you have not approved of look at things like your banking operations, your stock purchases, chats with confidence, etc. So I decided to make an ultra secure platform, and I have made some improvements to that, but basically it is that operations will be done in what I call a micro monolith, and the micro monolith will actually do the TLS all the way from it out to the world. That's why it's a monolith. It is the business in a nutshell. There will have to be several instances of those, and they will all have their own certificate. But their secret key, because it's a monolith, will be very easy kept guarded. One of the ways to keep that guarded is that any operator who starts this program will have to put in his own password, or her own password, and that will be used as a key to decrypt this. And in fact, this will never exist, the secret key will never exist outside of this executable, this program, unencrypted. You have to put in a password to get it decrypted so that this will run. So any data over here will be obfuscated with TLS, and the secret key, to have a look at that, will only be unencrypted inside the program. So one of the fundamental things to do this with is a thing called ACME, which is Automated Certificate Management. And thus far, one of the most premier ways of using ACME, Automated Certificate Management, which is when an organization runs a program to interact with the certificate authority, which approves a certificate, and then you have a certificate. And this is how it is usually run, by a program that is not within this. So a program that ran outside of this program would need that key in the clear. So that key, the ultra important secret certificate key, would have to be outside of an executable or a program in the organization. So that is the problem with taking a separate program to this and running ACME. So what I have developed is an ACME client that runs inside this program. It only operates with a key that's in memory, and anytime that key is outside, for example, to restart or to start another instance, it will be encrypted. And the only way to unencrypt it is by the operator starting this program, putting in his or her password. So, for about a year and a half, this platform, which I call SALSA, has been successfully running ACME from within the program. Most recently, I have improved it such that it checks the expiration of the certificate on a regular basis and determines whether it needs to run ACME to go to a certificate authority and get another key downloaded. So this program will never have to shut off. It runs perpetually, and when it determines an expiration of the certificate, it will automatically run a program that interacts with the certificate authority with a new secret key that is only known to the program. The secret key is only known to the program. The operator merely provides an encryption key that can be applied to it in order for it to be stored in the database. And in the case that this needs to restart. And perhaps a future improvement could be that it's not restored at all. It's only ever in memory. Moving on to the application that was first developed to run on this platform, is a program meant to store consumer data just as secure as all this. So the intent is that the consumer data can be stored in database persistently, but never be subject to prying eyes by anyone. Neither this operator or any other person running any of this will be able to decrypt data stored for a world consumer. The way this is done is somebody using this system will give a password, which is actually an encryption key, that will be used to encrypt data that goes into the database. Since that password is very secure via this TLS and this process here, nobody in the organization will have privy to that password, which is an encryption key for their data. That does present the issue of password recovery. So a system has been developed for password recovery, and for most consumers this will be somewhat familiar, where a series of questions are asked. And while this system is somewhat familiar because you'll have an operator just asking you a couple questions or even program, the particular one I developed is a little more rigorous, and also by all these things means not subject to the observation of anybody working in the system. And that is there will be questions, but the answer will be put in, and this password can be recovered from multiple chunks of this of the answers to these questions. So the number really has been settled on 5, and any 3 out of the 5 will recover your password. And most importantly, the only way you know whether you've put in the right things is when you use that password as an encryption key on a special piece of data, whether it can decrypt it or not. So functionally, no part of this program or anybody running it will ever be able to decrypt any of this data without input from the consumer out here. And when they do it, it will be through this program and not through an operator communicating with the end user. So to recap, this program can you start, it'll check for expiration of a certificate either at startup or during an ongoing repeated basis. It will create its own secret key that is unbeknownst to the operator or anybody else working at the business, and will establish a certificate that it gets approved with a certificate authority, and keeping the secret key hidden, it will now have a certificate that it can use to communicate securely via TLS with the outside world. That's all.